Alright, hello again. Let's take a look at some special factoring formulas that we should know since we're talking about factoring here. So let's look at these key three formulas which we've seen in the past. So let's recall what they are. Let's look at special factoring formulas. And the problems that are involved with them. Alright, special factoring formulas and factoring problems that require more than one or two steps, for example. Now let's recall first off the three formulas that we've seen in the past. All right. So the first one is the difference of squares formula, if you recall, right? Kind of something like a plus b times a minus b. Well, we know from previous chapter perhaps that this is going to be a squared minus b squared. That's why it's called the difference of two squares. Difference minus of two perfect squares. So in other words, you simply square the first term and square the second term and take the difference. And that's it. So you get the result of this product here. So we're going to go backwards. We're going to start on the right-hand side and end up with the left-hand side going backwards. All right? Look at the second formula. Let's look at the perfect square formula. A plus b quantity squared. Let's recall what that is. This is going to be a squared plus 2ab. So most students tend to forget about the middle term, which is 2ab. B there, sorry about that. Plus b squared. So a squared plus 2ab plus b squared is the formula we will use here. Alright? Now again, I'm going to give you the right side. You're going to come up with the left side for me. So the key is to figure out what a is and what b is, and then just basically write the answer down, which is the left side. When it comes to factoring, we're going backwards, right? So now there's tricks to this, so we'll talk about that later on. Alright? Let's look at the third one. It's very similar to the second one. It's just a minus b quantity squared. It's very similar. It's a squared. Instead of plus 2ab, it will be a minus 2ab plus b squared. So we call the second and third formulas are basically the same. You have a squared, you have 2ab, and b squared. The only difference is that you have plus here if it's a plus, you have minus here if it's a minus on a minus b. That is. Alright? So the trick here is to identify a and b for these problems and simply write the answer down. Again, I give you the right-hand side. You have to come up with the left-hand side, which is what factoring is, going backwards, right? Let's start with the first formula, the difference squared. Let's take a look at a problem involving it, right? For example, let's take a look at something like, let's start with a simple one here, x squared minus 16, right? So x squared, well, since it's being squared, it's a perfect square. 16 is a perfect square, and we're taking a difference, so this is the difference of two squares, right? So again, let's write down what a is, and based on our discussion on formula number one. So clearly you see that a is going to be equal to what? X, right? I hope you can see that, right? Since a squared is x squared, certainly a is equal to x. Now since b squared is 16, so b is going to be equal to, as you might guess, 4. So therefore, we simply write this answer down on the left side for x squared minus 16. So a plus b is going to be x plus 4. A minus b is going to be x minus 4. And that's it. So you simply write the answer down to come up with the factoring here in this section. So it's not going to be too hard at all, as you can see. As long as you can figure out what a is and what b is and know how to apply this formula. Of course, you have to know what the formula is, so memorize these three formulas, obviously. Alright? Let's try another one. Let's take a look at 25x squared minus 81y squared. Again, we have the difference, and we have two perfect squares again. So if a squared is 25x squared, then clearly you see that a must be what? 5x. If b squared is going to be 81y squared, clearly see that b is going to be 9y. Again, hopefully we can come up with that without too much difficulty. But again, the formula says what? A plus b, a minus b are the factors for that. So this is going to be a plus b, or 5x plus 9y, and a minus b, 5x minus 9y. And that's it. So you simply write the answer down once you see the formula can be applied. So not too bad at all. A plus b, a minus b. And that's it. Alright? Let's try this problem. What about x squared plus 49? X squared plus 49. Right, now this is, notice that this is two squares also, but this is the sum of two squares. So notice that we have no formula for that. So this formula, which only applies for the difference of two squares, cannot be used for this problem, the sum of two squares. And it turns out that the sum of two squares is not even going to be factorable. So let's keep that in mind. So the difference of squares is factorable. It's a plus b minus b. But the sum of two squares is not factorable. So we simply write not factorable in this problem, since it cannot be written as a product of two factors. Alright? So again, sum of two squares is not factorable, but difference of squares is factorable. Right? Let's try another problem involving this difference of squares concept. Let me go and clear out the screen. Let's go and try another problem. Okay, so let's go ahead and look at this one here. Let's look at x to the fourth, if you will, minus, let's say minus 81. All right? So is this the difference of two squares? Well, yes it is, because I can look at x to the fourth as x squared, and of course 81 is going to be what? 9 squared. Okay? So therefore this is the difference of two perfect squares. Can you see that minus here, right? Difference of two perfect squares. Except what's my a now? My a here is going to be what? X squared this time. Can you see that? Again, it's a squared minus b squared. Can you see that? A squared minus b squared. Okay, so b is 9. All right, hopefully you see that. Okay, then again, the formula says what? A plus b, a minus b. So I have x squared plus 9 times x squared minus 9. Can we see that? A plus b, a minus b. Can we see that? All right. But wait a minute now. We're still not quite finished yet. Because now look at these answers here. Well, these factors, if you will. X squared plus 9. Okay. Now these are perfect squares, aren't they? X squared and 9. But again, since we're adding them, and I mentioned earlier that the sum of two squares is not factorable. So here we're done. This factor, we're done. But what about this one, though? X squared minus 9. Are we done here? And the answer is no, we're not. I can still factor this, right? I can apply the difference of squares again, because that's a perfect square, and 9 is a perfect square. So I can apply the formula again, except I apply it with a being what? X this time, and b being what? Not 9 earlier, but what? 3 this time. Can we see that? Because 9 is what? 3 squared. So therefore, the final answer will be x squared plus 9. Just bring that along, right? But x squared minus 9 will factor to what? X plus 3, right? A plus b, new a, new b, a plus b times what? A minus b, x minus 3. Can we see that? So therefore, we have x squared plus 9 times x plus 3 times x minus 3, okay? So you see the ice cream truck getting a little louder in the background, perhaps, all right? Let's try another one here. Let's look at another problem, all right? Let's look at this problem here. Let's look at how about x squared plus 8x plus 16, all right? Now I have 3 terms now, all right? Now, is this of one of the forms I mentioned earlier? Okay, so remember the 3 forms we have. I'll put them down again. A squared minus b squared is what? A plus b, a minus b. All right. We also have a squared plus 2ab plus b squared, and this was what? A plus b quantity squared. Okay. So I'll leave off the third one since this is going to be of the second type here. I hope you can recognize that. Now, first of all, how do I recognize that this is going to be of the second type? How do I know that this is of this trinomial here? Well, first observe a couple of things. That the first term and the last term are what? Perfect squares. Can you see that? X squared, 16. These are perfect squares. So therefore, you start thinking about this formula here at this point. If the first term and the last term are perfect squares, then you start thinking about this formula. But it's actually not quite done yet, right? In other words, it's still not quite a perfect, not quite a perfect square, not quite the perfect square of this type yet. We still need to check the middle here, right? So, but first, how do I check that though? So since that's a perfect square and that's a perfect square, that lets me identify A and B. So my A in this problem is going to be what? It's going to be X, and my B is going to be what? 4, all right? Now, I still got to check the 2AB. Remember 2AB means what? We multiply A and B together and we double it, right, to get 2AB. So let's do that. Let's check that. let's multiply a and b together. So we're working backwards a little bit, right? So x times 4 is what? 4x. Let's double it. If I double 4x, what do I get? 8x. That's right. So do I have 8x here? Well, yes, I do. So therefore, this trinomial is of this type. And therefore, the factoring of it will be what? A plus b, quantity what? Squared. So this is going to be x plus 4, right? A plus b. There's my a, there's my b, quantity squared. Okay? So once you recognize it, you just write the answer down. So no big deal here. Okay? So can we see that? Let's try another one here. Let me squeeze one right below here. How about how about this one? How about 9x squared plus 12xy, all right, plus 4y squared. Let's try that. 9x squared plus 12xy plus 4y squared. Again, look at the first term and look at the last term, all right? Are these perfect squares? And the answer is yes, they are. 9x squared is a perfect square. 4y squared is also a perfect square. Well, in that case, then, it might be of this type. Now I have to identify what? Based on that, I have to identify what? A and B, all right? So what's my A? My A is what? If A squared is 9x squared, what's A? Well, A is going to be 3x. And hopefully you see that. What's my B going to be, though? If B squared is 4y squared, right? B squared here, 4y squared. What's B going to be? Well, hopefully you see it's going to be 2y. All right? So, in that case, I need to still check the 2ab term. Again, 2ab means what? You multiply A and B and you double it. So let's multiply A and B together. Okay, so working backwards. So 3x times 2y is what? 6xy. All right, can we see that? 3x times 2y, 6xy. Let's double it. If I double it, do I have 12xy? Yes, I do, right? That's what I have here. I have 12xy in the problem. So therefore, this trinomial is of this type. And the factoring will be a plus b quantity squared. So the answer is just going to be 3x plus 2y quantity what? Squared. As our solution here. Okay? So this is the solution we come up with. Once we recognize it's of the form, we just apply this formula, and that's it for the factoring. Okay? Not too bad. Let's try another one. And let's look at this one right here. All right. Let's see here. How about x squared minus 14x plus 49? Okay. Let's go ahead and try this one here. All right. So, what form is that? Well, again, this will be of the third form. Let me give you the third formula again. We have what? Well, let me give it to you this way. A squared minus 2ab plus b squared is equal to a minus b quantity squared. Okay, let's recall this third formula I wrote down on the first screen here. All right. So this will be of this type. Again, how do I recognize that though? Well, look at the first term. Look at the last term. Is that a perfect square? Yes, it is. Is this a perfect square? Yes, it is. So let's identify a and b. A is what? X here. Can we see that? What's b? If b squared is 49, what's b? 7. All right? Again, check the 2ab. 2ab again means what? You multiply a and b and you double it. Okay, again, the middle term has to be negative because 2ab is minus, right? So let's look at a and b. That's going to be 7x. All right? Let's double it. What do I get? 14x. Well, look, I do have 14x. So I'm good. So therefore, this trinomial is going to be of this type. So therefore, I can just write the answer down. A minus b quantity squared. So it's going to be x minus 7, because a is x, b is 7, right? A minus b quantity what? Squared. Okay, so these problems are very quick. Once you recognize them, what formula to use, and you recognize a and b, then you just write the answer down. Okay, not too bad at all. Let's try another one. All right, let's look at this one. Let's look at 100x squared minus 180x plus 81. Okay? Again, look at the first term, look at the last term. Are these perfect squares? And the answer is yes, they are. So what's A again? Again, once you recognize that that's perfect square, let's go ahead and identify A and B. So what's A? If A squared is 100x squared, what's A? 10x. I hope you see that. What's B if B squared is 81? Well, it's going to be 9. All right? So let's check the middle term again. Check this 180 here, right? So if I multiply a and b and double it, do I get 180? Let's see. 10x times 9 is what? 90x. Double it. So what do I get? 180x. I do have that. So therefore, again, this is of this formula here, because the middle term is negative, all right? So therefore, the answer is going to be what? A minus b quantity squared. So it's just going to be 10x minus 9, right? A minus b quantity what? Squared. All right, so we have our result there without too much trouble here. All right, let's try this one. All right, let's look at x squared minus, let's say x squared minus, minus 13x there. Sorry, just getting a drink there. Minus 13x. Let's make it plus 36. All right, let's look at that one. All right. Now, is the first term a perfect square? Yes, it is. So a is equal to x, all right? Is 36 a perfect square, the last term? Yes, it is. So b is equal to what? 6, all right? Again, let's check the middle term. Again, I still have to check the middle term, right? Let's multiply a and b together. So x times 6 is what? 6x. Double it. 12x. Okay, do I have 12x? Uh-oh. I don't have 12x here. Can we see that? So since I don't have a 12x, is this of that form up here? And the answer is no. This trinomial is not of this form. So do I answer then not factorable since I can't factor that way? So is the answer not factorable? Well, maybe, but I need to check that. Well, this trinomial is not too hard to factor, right? Remember that? This is of the form x squared plus bx plus c. This is from 8.2 homework, you remember, right? So that factors into true binomials. Remember that, right? Okay, now I cannot use this formula because the middle term does not check out. Can we see that? So this formula does not apply for this problem, even though I have perfect squares on the ends here. Okay? So I need to do it a different way. Now, if I can't factor it, then I say not factorable. But in this case, it's going to work out. Because you remember from 8.2, what two numbers will multiply to 36 and add up to negative 13? You'll see that the two numbers will be negative 9 and negative 4. So negative 9 times negative 4, positive 36. Negative 9 plus negative 4, negative 13. So don't say the answer is not factorable. It is factorable. It's what? X minus 9 times x minus 4. So if we cannot factor it using one of the formulas, then we need to do it the way we did it in previous sections, if you will, in terms of the factoring. Does that make sense? Are we okay on that? All right. Let's go ahead and try a couple more now. Give you some problems to post in Blackboard. Let's go and try a few more problems. A couple more problems. Let's go and try this one here. All right. Let's look at the 18a cubed plus 24a squared. All right. And plus 8a. Okay. 4 out of 10. So let's look at factoring this trinomial here. But again, the first thing we do when it comes to factoring is what? Look for the GCF, right? Remember, always take out the GCF first. In this case, do I have a GCF? In previous examples, I didn't have one, but in this example, I do have one. Can we see that? 18a cubed, 24a squared, 8a, they all have something in common other than 1. In fact, what's in common is going to be what? It's going to be what? 2. 18, 24, and 8 is going to be 2, all right? So 2 what? A cubed, a squared, a lowest power wins for GCF, remember that? So 2a in common. They all have 2a in common. So I can take out a 2a times what? Well, what's left? And if I take out 2a from this trinomial, 9a squared, can we see that? To get the 18a cubed back, all right? Plus what? 2a into 24a squared will be what? 12a, all right? Hopefully we see that. 2a into 8a is going to be what? 4 times. Okay? So again, make sure we see that here in terms of taking out the GCF first. Again, that's the first rule of thumb when it comes to factoring any polynomial. Take out the GCF first. Okay? Now, is this of the form that we can recognize? Well, again, is 9a squared a perfect square? Yes, it is. Is 4 a perfect square? Yes, it is. So from the formula, then, my 9a squared is really, then, that gives me the a of what? So a is really 3a. This is a in the formula, all right? This is a in the problem here, okay? So a from the formula says that it's going to be 3a here, because a squared is what? 9a squared, so a must be 3a. Well, what's b in this problem? Well, b is going to be what? 2, because b squared is 4. So again, let's check the middle here, right? So well, actually, let me put b below. B is equal to 2. And let's check a times b. 6a, all right? Double it. 12a. If I double it, do I have 12a? Yes, I do. So therefore, this is one of the perfect square formulas that we've been working with here. Okay? So therefore, the final answer will be 2a. Just bring down the GCF I took out, times what? Remember the formula says what? A plus b quantity squared. So it'll be 3a plus 2. 3a plus 2 quantity squared. Okay, again, the formula I'm using here is what? A plus b quantity squared. And this was what? A squared plus 2ab plus b squared. And we said that this trinomial in the parentheses is of this form, so therefore I can apply this formula to factor it. So therefore I have my final solution. Okay, so take out the GCF first here, as always. All right, let's try another one. All right, let's look at this situation here. And how about 8n squared minus 72? All right, let's try that. Again, take out the GCF first. It's going to be 8. So 8 comes out. Excuse me. All right. So 8 comes out. So what do I have then? I have n squared minus what? 9. Can we see that? And is n squared minus 9 one of those formulas that we've been working with here? Yes, it is. Difference of two squares, right? So in this case, my a is n. My b is what? 3. And if you remember the formula, it says what? A plus b, a minus b. Right? That's a squared minus b squared, right? So this is of the form a squared minus b squared. Difference of two squares. So therefore, my final answer is going to be 8, bring down the GCF, times what? A plus b, n plus 3. All right? That's a 3 there. Sorry about that. Times what? A minus b, n minus 3. As our solution. All right? So there we have our solution here. Again, taking out the GCF and applying the 3 formulas that we know in this section here. Okay? So let me see if I have one more for you here. Yeah, let's go and try one more. Let me turn off the screen. I'll use some problems to post on Blackboard. Let's try one more factoring problem. All right? Let's look at ay squared minus by squared. All right? Minus a plus b. Minus a plus b. Okay, let's try to factor this one. Now this one has 4 terms, right? So that's grouping, right? Factor by grouping when we get a polynomial of 4 terms. Remember that? So first 2 terms as a group, next 2 terms as another group. Okay? So let's look at the first group here. Okay? First group, what's the GCF? Well, they have y squared in common. I'm going to take that out. Y squared times a minus b left over. Can we see that? All right? Since the third term is negative, let me take out a negative 1 here, all right? And all they have is 1 in common in terms of a and b anyways, right? So let me take out, since it's negative on the third term, remember for factor by grouping, you should take out a negative number in that case. So let me take out negative 1, so I have a minus b left over. Now you may say, how come it's minus b and not plus b? Well, again, check your factoring here. Negative 1 times a is what? Negative a. Negative 1 times negative b is what? Positive b. Okay? So this is correct. All right. Now, what's in common? Well, look, a minus b in common here, right? Factor by grouping. So a minus b taken out. What's left? Y squared minus 1. All right. Can we see that? Now, let's go one step further because this y squared minus 1 is factorable. This is what? Difference of 2 squares again. Y squared is a perfect square. 1 is a perfect square. So in this case, my a is going to be the y. My b from a and b from the formula, right, is going to be the 1. So for the formula, to use the formulas, you want to identify a and b for a given problem. That makes it easier for you to apply the formula. So now we have a minus b, all right, times what? So this a minus b is from the problem here. So be careful here, right? The factoring is a minus b, a plus b, right? So, but from the formula, my a is going to be what? Y, my b is going to be 1. So y minus 1 times y plus 1. A minus b, a plus b. All right? That's our final solution. Okay? Okay, now let's take a look at a special type of factoring called the U substitution. Now, here's what I mean by that. This is where you try to rewrite a polynomial in terms of the variable u, and then you try to factor it in terms of u, and then write back the original answer. So let's take a look at this problem here. So consider this problem here, for example. Let's take a look at something like x to the fourth minus minus 8x squared, for example, minus 48. Okay, so x to the fourth minus 8x squared minus 4. Let's go and factor this polynomial. All right. So now, since x to the fourth, this is it's a little bit more challenging to factor, right? But we can do a u substitution and rewrite this in terms of u. Notice that the first exponent is twice the second exponent. So you can let u be the lower powered exponent. So let's go and let u, if you will, be x squared. Now let's rewrite this in terms of the variable u. So what's x to the fourth in terms of u? Well, if u is going to be x squared, x to the fourth. So to get x to the fourth, I need to what? I need to square the u, because x squared is x to the fourth, right? So x to the fourth is going to be u squared. Can we see that? So let me say that. Let's observe on the side here, maybe then, that if u is equal to x squared and you square both sides, for example, right? Square both sides, you get u squared is going to be x to the fourth. So therefore, x to the fourth can be rewritten in terms of u as u squared. So this polynomial becomes u squared minus 8x squared, but x squared is what? U. So 8u minus 48. Can we see that? And then we can factor that. Now it's a standard polynomial we factored in the past. So that's simply going to be factored into two binomials, right? As you mentioned, right? As we mentioned here. So u and u here, right? So two numbers that multiply to negative 48 add up to 8 is going to be what? It's going to be 12 and 4, right? So negative 12 and positive 4 in particular. So u minus 12 and u plus 4, because that will add up to negative 8. That multiplies to negative 48. Right? Now, again, that's not the final answer, because the original problem is in terms of x. So I need to rewrite this answer in terms of x. But what's u here? U is simply x squared. Just plug the x squared back in for u. So final answer will be x squared minus 12 times x squared plus 4. Can we see that? So this is the solution we're looking for in terms of the factoring. All right? So let's go ahead and try another one. Let's take a look at this problem then. All right, let's take a look at something like this here. Let's take a look at x to the fourth minus 8x squared minus 9. All right. So again, let's observe that the first power is twice the second power. So let u be the lower power term. So we're going to let u be what? X squared again. So x to the fourth is going to be what in terms of u? Well, u squared again, just like here. All right, minus 8u, okay, so 8x squared, 8u again, minus 9. All right, so again, easy polynomial to factor. That'll be what? U minus 9, and what else? U plus 1, because two numbers that multiply negative 9 add up to negative 8 or negative 9, and positive 1. Can we see that? So make sure we recall that concept, but that's not too bad. All right, but again, write it in terms of x squared, so therefore the final answer is going to be what? X squared minus 9, all right, and x squared plus 1. Plug the x back in for u. Right? But look, observe that I mentioned final answer, but actually this is not the final answer, because let's observe that x squared minus 9 here, that's the difference of two squares. This is going to be factorable as well. So I can apply the difference of squares formula to the x squared minus 9 factor. This is not factorable, so that I can leave that as is. But this is going to be what then? X plus what? 3 times x, oops, that's an x there, minus 3. X plus 3, x minus 3, that's an x right there, sorry about that. And again, just bring down the x squared plus 1. All right, so this is the final factoring solution here, completely factored in terms of this polynomial. All right, let's go ahead and try another one. Let me go and clear out. Actually, let me put it down here. Let's try it down here. So we fit it into the screen here. Let's take a look at something like x squared y squared. Let's factor x squared y squared minus 9xy. Plus 20. All right. So this one's a little more tricky, but again, observe that 2 is double the 1 here, visible 1 on the exponents, right? So, but yet x and y, right? But let's observe that x squared y squared can be looked at as xy quantity squared. Can we see that? So what I'm suggesting here then is let u be the xy. This to be my u. So we're going to let u be xy for this problem. So in terms of u then, let me write down here if I can fit it in. It's going to be what? X squared y squared is going to be u squared, right? So u squared, u there, sorry about that, minus 9xy, well, minus 9u plus 20. That's a 20 there, sorry about that, and that's a u right there, sorry about that. All right, so therefore we can factor that again easily as what? U minus 5 and u minus 4, because those will multiply to positive 20, add up to negative 9. Again, what's u though? U is going to be xy. So final answer should be xy minus 5 and xy minus 4. Alright, so hopefully we can see that result here in terms of using the u substitution in terms of factoring these types of polynomials here. Alright, now let's move on to the cubic forms. Let me go ahead and clear out this screen here. Alright, now let's go ahead and look at the two cubic formulas for factoring that we haven't seen in the past. Let's take a look at something like the first one here of the form a cubed plus b cubed. Alright, this factors to a plus b, alright, times, I'll show you how to give you some tips on how to memorize this in a second. Alright, a squared minus ab plus b squared. Alright, so a cubed plus b cubed is going to be factorable. So sum of two cubes is factorable. Factors into a plus b times a squared minus ab plus b squared. Right? Let's look at a difference of two cubes. That's also factorable with a slightly different formula. Let's take a look at that formula here. Show you, get some tips on how to memorize it. A cubed minus b cubed. Well, the first factor is going to be a minus b this time. That's a b there. All right. Times a squared. This time it's going to be plus ab plus b squared. Alright, so the two formulas are going to be a plus b for the first one, a squared minus ab plus b squared for the sum of two cubes. And for the difference of two cubes, it will be a minus b times a squared plus ab plus b squared. Now, if you notice, both the first and second factors are essentially the same for both of them, right? The first factor on both of them have what? A and b in it. And if it's a sum, it'll be plus. If it's a difference, it'll be minus, all right, for the first factor. But for the second factor, again, the terms are exactly the same. A squared for the first term, ab for the second term, b squared for the third term. All right? Except that if it's a sum of two cubes, it'll be minus ab, the middle term will be negative. If it's the difference of two cubes, it'll be a different sign, positive ab. The ab term will be positive. So this is the way we're going to memorize this, if you will. Again, the trick is to use these forms of what is, again, just like the other forms, identify a and b, and then apply the formula. So let's look at a problem like that. For example, start with a simple problem. Look at something like, for example, x cubed. Let's go and factor x cubed plus what? 64y cubed, for example, right? So the first one is a perfect cube, x cubed, obviously, but so is 64y cubed, because we can look at 64y cubed as what? 4y quantity cubed, because 4 cubed, if you use your calculator a little bit, there's going to be 64, right? So what I'm suggesting here then, from the formula here, so this could be the sum of two cubes here, right? We use the first formula for this problem. So my a is going to be what? Just the x, all right? My b will be what? In this case, b cubed is 64y cubed, so b must be 4y. So b will be the 4y as I applied this formula here, all right? So therefore, the final answer, once we apply the formula, we just write the answer down, basically, right? So a plus b, so that's going to be x plus 4y, all right, times a squared. Well, the square of a is just x, so x squared, right? Since a is x. Minus ab, so let's multiply a and b together. So a times b, x times 4y is just 4xy. So this is a times b, right? So minus 4xy. All right, plus b squared. So here's b, 4y squared. You get what? 16y squared. Square right there. All right, so that's it. So once you apply the formula, you just write it down basically, and that is it. All right, so not too bad at all. Let's try another one here. All right, let's take a look at something like, how about 8x cubed minus 125y cubed. All right. Again, how should we look at a and b? Well, again, the cube root of a is what? 2. So my a is going to be 2x, if you think about it a little bit. What's the cube root of 125 in the calculator perhaps, right? 5, right? So b is going to be simply 5y, because 5 cubed is 125. All right? So there's a, there's b. Again, the trick is to identify a and b. This time we have a difference of 2 cubed, so therefore we're applying the second formula now. All right? So a minus b, so that's going to be what? 2x minus 5y, all right? Times, again, it's exactly the same terms, right? A squared, AB, and B, right? And they're all positive since we're for a difference of 2 cubes. So a squared is going to be what? What's 2x squared? Well, that's 4x squared. All right? Plus AB. Let's multiply a and b together down here. 2x times 5y is 10xy. All right? So be plus 10xy plus ab. All right? Plus b squared. Again, b is 5y, so b squared is what? 25y squared. All right? So there we have it, right? In terms of applying the cubic formulas here, right? Not too bad at all. The trick is to figure out what a and b are, and then apply the formula here. Let's just do one more to finish out. Let me go and clear out the screen here. All right, let's take a look at this problem here then. What about something like 16x cubed y minus 2y to the fourth. Minus 2y to the fourth. All right? But let's observe that these are not perfect cubes, because 16 is not and 2 is not. But they do have what? A GCF, a greatest common factor. So we should always look to take that out before we begin any factoring process, right? Or use any formula. So what's the GCF here? Well, you see they have 2 in common, and what else? And a y in common. So let's take out a 2y, if you will. So what's left? Well, we have 8x cubed left then, right? And then minus what? Y cubed. And clearly, this is a cubic form because, again, cube root of 8 is 2, right? So we can apply that formula we had earlier, right? So my a is going to be 2x, as you can see. My b is just going to be y because that's just y cubed, all right? So then this cubic difference of 2 cubes is going to factor to what? 2x minus y, a minus b, right? Remember that, oh, that was the first factor. Times what? A squared, right? So again, write the formula again if it helps you, right? So a cubed minus b cubed is what? A minus b times a squared plus ab plus b squared. Remember, for the minus difference of 2 cubes, the ab term has to be positive, right? So a minus b I mentioned here, so 2x minus y. A squared, my a is 2x, so therefore this will be 4x squared once again, right? A squared. Plus AB, so let's multiply a and b together. That's just 2xy if I do that. So plus 2xy, all right? And then plus b squared is just y squared. All right? So there we have it. Well, actually, I shouldn't circle that because, let me cross-scribble this off, because that's just part of the answer, right? Don't forget my what? GCF I took out earlier. So final answer should be 2y, all right? Bring down the GCF again, and 2x minus y, all right, times this trinomial. 4x squared plus 2xy plus y squared. All right, now I can circle that result as my final answer. All right, completely factored. All right, so again, take out the GCF first for any problem, though. But recall, let's see if we can apply these 2 cubic formulas correctly on the homework. All right, so let's go ahead and take a look at the Blackboard problems I have for you then, for you to submit and into Blackboard. Let me go and clear out the screen. All right, so let's take a look at these 3 problems right here. Okay, so I want you to factor these 3 polynomials using the techniques mentioned in this section. All right, post the answers into Blackboard. All right, take care and have a great day.